Hello students, so in this video we are going to start our organic chemistry. So just let us discuss some basics about the organic compounds. So organic compounds, they are basically of two types. One is acyclic and second one is cyclic. Okay, acyclic is nothing but your open chain compounds and cyclic means closed chain compounds. Okay, then this acyclic means open chain compounds are further subdivided into saturated and unsaturated. Saturated means in which you have single bonds present. Okay, means carbon carbon single bonds are present. Those type of organic compounds are called saturated organic compounds. And wherever you will be getting carbon carbon double bonds or carbon carbon triple bonds, those compounds are called unsaturated compounds. Okay, means if multiple bonds are present, then the compound is called unsaturated compound, and if only single bonds are present, then the compound is called a saturated compound. Okay, on the other hand, the cyclic compounds, they are again subdivided into homocyclic and heterocyclic. Okay, homocyclic means if the cycle is only made up of carbons. Okay, so homocyclic compounds are those compounds in which you have only carbon bonds in the cycles. Say only carbon atoms are present in the ring, then it is called a homocyclic compound. Heterocyclic compounds are those compounds in which you have say if you have any other atom means other than carbon, then it is called a heterocyclic compound. Okay, so this homocyclic are again further subdivided into alicyclic and aromatic compounds. Okay, so just let us go to the next part. So first we will be discussing about IUPAC nomenclature of organic compounds. Okay, this is the most basic thing that you have to study for organic compounds, because whatever you want to do, say reaction mechanism or anything, say organic conversions or anything, if you don't know the name of the compound, it will be a little bit difficult for you. Okay, so first of all, what you have to do, you have to know how to write the IUPAC nomenclature for organic compounds. Okay, so this is the basic structure of IUPAC nomenclature. Say for writing an IUPAC name or IUPAC nomenclature, this is the basic structure that you should follow. Okay, so this is the basic structure. So in this structure we have three parts. First part is your prefix, second part is your word root, and third part is your suffix. Okay, so you just see that word root means what. Say you have means the number of carbon atoms. Okay, so if you have one carbon atom, then it is called methane. For two carbon atoms, it is called propane. For three, it is called butane. So like that. So word root will just tell you about the number of carbon atoms that are present. Okay, so on the basis of the number of carbon atoms, you will write the name for the parent chain. Okay, then we have a part called prefix and a part called suffix. Okay, so prefix means whichever is written before the parent chain, means before the name of the parent chain we write names of some, say substituents or say different side chains, we write them before the name of the parent chain. Okay, so those things comes into the prefix. Okay, and in suffix what we have, we basically have the functional group or the multiple bonds present. Okay, so multiple bonds and functional groups are written in the suffix, and substituents and say different side chains, those are written in the prefix. Okay, and in the word root we have the name of the parent hydrocarbon. Okay, so you see this suffix, it is also subdivided into two parts. One is your primary, second one is secondary. Primary suffix tells us about the substituents, say the position of substituents, say number of substituents, like those things. Okay, and secondary prefix will tell you about the nature of the carbon chain. Nature of the carbon chain means it is a open chain or a closed chain. Say if you have a closed chain, then we use the prefix cyclo. Okay, and if it is an open chain, then we don't use anything, means any prefix we don't use it. Okay, whereas for suffix also we have two parts, primary suffix and secondary suffix. So in primary suffix what we will get, say nature of the carbon carbon bond. Say if you have a double bond, say multiple bonds are present, say double bond or triple bond, then those things will be written before the functional groups, which is going to come in the secondary suffix. Okay, so this is the basic structure, say basic formula of a IUPAC nomenclature. So first you will write prefix, then your word root, which consists of the parent chain, and then you will write the suffix, which includes your multiple bonds or functional groups. Okay, so how we will consider that which functional group will be acting as a suffix and which one will be acting as a prefix. Say you have a hydrocarbon in which you have a two functional groups. Say you have alcohol functional group and you have a aldehyde functional group. Okay, so if you have such type of compounds now where more than one functional group is present, then you will be confused that which functional group you will write in suffix and which one will be writing in prefix. Okay, so for that you have to use this priority order. Okay, so priority order, it tells us that which functional group is more stronger compared to the other. Okay, so whichever functional group is more stronger will be going to the suffix, and whichever is less, means say weaker, will be going to the prefix. So in case of an aldehyde and an alcohol, what we see that alcohol is a weaker functional group compared to a aldehyde. Okay, so CHO, since it is a stronger functional group than OH, that's why what will happen if you have both these groups present in the same organic compound, then OH will become the prefix and CHO will become the suffix. Okay, so this priority order will help you to identify that which functional group will be becoming the suffix and which one will be the prefix. So for that, what you have to do, you have to memorize this priority order. Okay, so next you see the functional groups. These are of two types. Okay, first one is type A functional groups. Type A functional groups are those functional groups which are always written in prefix. Okay, there is no suffix for type A functional groups. Means type A functional groups will always be written at the start of the IUPAC nomenclature. Okay, means they will always be written as a prefix. Okay, and you also have type B functional groups. Type B functional groups, which are those which has both suffix and prefixes. Okay, now you see, say let us come back to type A functional group. Type A functional group means you have this epoxide, then this alkoxy, then this you have halogens, fluorine, chlorine, bromine, iodine, you have nitro group and you have nitroso group. Okay, so these are the 8 different types of functional groups which are written only in prefix. Okay, so if you have any of this type A functional groups now, then you will not be confused. You will just simply write these names in the prefix only. Okay, but if you have this type B functional groups, say carboxylic acid, say your ester, then you have acid chloride, amide, cyanide, isocyanide, aldehyde, then you have ketone, then alcohol, then thiol and amine, then you have this sulfonic acid, you have this anhydride. So all these things now, say all these functional groups which belong to this means type B functional groups. So for these functional groups, they can be written both as prefix and as suffix. Okay, so for type B functional groups, what you have to do, you have to use this priority order. Okay, this is very very important, because if you don't know this priority order, then you won't be able to identify between type B functional groups which will be suffix and which will be prefix. Okay, so you just have to memorize the type A functional groups, type B functional groups and your priority order. Okay, rest, let us come to the rules how we write this IUPAC nomenclature. Okay, so you see in all the different textbooks you will get so many rules, means all the rules are same only, just they have just separated it and written, so it becomes little bit complicated for you to understand. Okay, so I have just summarized all the rules and I gave you a short way how to write. You see, first of all, what you will do, you will just identify the longest chain. Okay, according to first rule, what you have to do, you just have to identify the longest chain. Say you have this one, say this is the hydrocarbon chain. Okay, so in this one you have OH group in this position and you have a Cl group in this position. Okay, so now what you have to do, as for our first rule, we have to identify the longest chain. Okay, so the longest chain is identified. This is the longest chain, 1 2 3 4 5 6 7. You have 7 carbon atoms. Okay, so it is a heptane chain. Okay, this means the parent chain is a heptane. Okay, second rule is that you have to number the carbon atoms so that the functional groups gets, say functional group or multiple bond or substituent, whichever whatever is present, they should get the least possible number. Okay, least possible number means, say you have this one, say let us give one more substituent here, this is a CH3. Okay, this one. So in this one we can number this longest chain from two sides. Okay, one we can do it from left to right, so we will get 1, we will get 2, 3, 4, 5, 6 and 7. Okay, so we'll get this 1 2 3 4 5 6 7. Now in this you just count, means you just sum up the numbers of the, means the position of the substituents and the functional groups. Okay, in 2 position we have Cl group, so it will be 2 plus, in 5 position we have CH3, so it will be 5 plus, in 6 position we have OH, so it is 6. So it is giving us 11 12 13, so the sum is 13. Okay, now same thing, what we can do if we number it from, say, right to left. Okay, say this will be 1, this will be 2, this is 3, this is 4, this is 5, 6 and this one will be 7. Okay, like this. So in this numbering what we are getting OH in 2 position and CH3 in 3 position and Cl in 6 position. So our sum is 11 this time. Okay, so you see this is called your least sum rule. Okay, means lowest sum rule. So what you will follow whenever you will get this type of organic compounds, now you just sum up the position of the substituents and functional group, and whichever you get lowest number, now you take that one, the highest number will be the wrong one. Okay, means we have to number the longest chain in such a way that the functional groups or substituents or multiple bonds, they get the least possible number. Okay, means the arrangement should be done such a way that the functional group, substituents and multiple bond gets the least number. Okay, this is our second rule. Third rule is that we have to write the name of the substituents in alphabetical order. Okay, say in this one what we will do, for this one we have this OH is a functional group, and this one is a type, OH is a type B functional group, and Cl is a type A functional group. Okay, and CH3 is a substituent. So for this compound, the name will be written like this. It will be, let me just erase this one. The name will be, alphabetically you see this CH3, this is called methyl, and this is called chloro. So C comes first, so it will be 6 chloro, then you will have 3 methyl, and then this is the prefix part. Okay, 6 chloro 3 methyl is the prefix part. Then we have 7 carbons. 7 carbon means it is a heptane. Okay, just don't give space, I don't means just you write in the same line. Okay, heptane, and in 2 position you have alcohol functional group, so it is heptanol. Okay, so the IPC name for this compound is 6 chloro 3 methyl heptane 2 all. Okay, so in this way you have to write. So the third rule says that say if you have more than one substituent, then you will write them in alphabetical order. Okay, so since C comes first then M na, so that's why you have written chloro first and then you have written methyl. Okay, and for order of priority, what we will do, functional groups will always get the first priority, then multiple bonds and then substituents. Okay, now see, if more than one substituent is present, then we will use these prefixes such as di, tri, tetra, like this. Okay, so if 2 chlorine groups are present, then it will be dichloro. If 3 chlorine are present, then it will be trichloro. Okay, now if this one, say the fifth rule says that if you have side chains present. Okay, so side chains, if they are present, then we will write a separate IUPAC nomenclature for the side chains, and we'll just give it in brackets. Okay, so when you come to examples, we'll just learn all these things. And the last rule says that if more than one substituent present in same position, then alphabetical order is followed. Okay, say you have this one, say this example you take, say you have both chlorine and fluorine in present in same, say this. So in this one, what you have, say you have a chlorine present here and you have a bromine present here. Okay, now what we'll get, see, if we count from this side, say 1 2 3 4 5. Okay, then also in 2 position we are getting chlorine and 4 position we are getting bromine. And if you count from the other side, say this one is 1 2 3 4 5. Okay, then also if you sum up, you will get the same number, say 2 plus 4 is 6, and this one also 2 plus 4 will be 6. Okay, then in this case, which side you will choose? Okay, so here you have to check the alphabetical order. Okay, since B comes first, so we will take this order. So it will be 2 bromo 4 chloro. Okay, 2 bromo 4 chloro, and since there are 5, so it is pentane. Okay, 2 bromo 4 chloro pentane. So this is the way that you have to follow. Okay, so these are the 6 rules that you have to follow, and if you learn these 6 rules and follow these 6 rules now, you can write IUPAC nomenclature for any compounds. Okay, so let us come to some examples. See, these are few examples that I have taken. So if you do discuss this, then I hope you will understand. So first let us come to number 1. You see this one, same example, just now we have discussed this one, same like this one. So here you have a heptane, means 7 carbon chain, and first position and 7th position you have bromine and chlorine. Okay, so since bromine alphabetically it comes first, so we'll start numbering from this carbon where bromine is attached. Okay, so this one will be 1 bromo 7 chloro heptane. Okay, this is very simple. Second one, you see you have this one, a double bond present and a chlorine present. Okay, now chlorine is a type A functional group, and type A functional groups are always written in prefix. Okay, and I told you that whatever is written in prefix na, they are also called as substituents. Okay, and whatever is written in suffix, they are considered as functional groups. So according to priority order, if you see, say in the rule we had a priority order, say this one, where functional groups are getting more priority than multiple bonds and then substituents. Okay, so since multiple bond is a higher priority than substituents, so in this case we'll start numbering from the side, say from left to right we'll start numbering, because if you go from left to right, then you will get the double bond say quickly. Okay, because in 2 position we'll get the double bond, and if you start numbering from right to left, we'll get the double bond in 3 position. Okay, so that's why you'll start numbering from that side, whichever reaches to the double bond more easily. Okay, then you see number 3. Number 3, you have 2 double bonds. Okay, so 2 double bond means, you see, we should consider the longest chain in such a way that all the multiple bonds should be present. Okay, means both the double bond should be present in the longest chain. So we have to number it from this carbon, because in this carbon we have a chlorine group also attached. Okay, so it will be 1 2 3 4, so 4 carbon, and you see in 3rd position we have this substituent, say a side chain is there. So this side chain, it has another substituent. Okay, side chain also has a functional group. So I told you, say rule number 2 or rule number 3, it was there, if you have a side chain, then it has to be named separately and have to be written in brackets. Okay, so you see this one is nothing but 2 carbon with a chlorine, so it is chloroethyl. So it is present in 3 position, and in first position you have chloro. So if first position you write chloro, 3 position you write chloroethyl, and then you have 4 carbon, so it is butane, so buta, and 2 double bonds, so buta 1,3 diene, because 2 double bonds are present. Okay, so one thing you remember, if it is a say only 1 double bond is present, so it is but 1 in or but 2 in, like that. Okay, but if it is say more than one double bond is present, say diene or triene, then always write this A. Okay, it will be butadiene or pentadiene. Okay, and if it is only one multiple bond, then it will be pentene, butene, hexene, like that. Okay, then this one, the fourth example, say fourth example, you have a double bond and a triple bond. Okay, now if you go from left to right, in first position we are getting a double bond, and if you go from right to left, we are getting a triple bond in the first position. Okay, means both side gives you multiple bonds in the first position. Then in this case we have to choose the side which gives you the double bond easily. Okay, because double bonds gets more preference compared to your triple bonds. Okay, because if their position is same, then double bond is getting more preference. So this is the numbering, it is pent 1 in 4 ion. Okay, now in this one you see, say question number, example number 5. Example number 5, if you go from right to left, we are getting a triple bond in one position, and if you go from left to right, we are getting a double bond in two position. Okay, now if this is the case, then we have to take that side from which we are getting multiple bonds more quickly. Okay, so this time triple bond will be given more preference because this position of the triple bond is nearer compared to that of the double bond. Okay, in the first position triple bond is present if you count from right to left, so this name is hex 4 in 1 ion. Okay, then number 6, you see, this is the longest chain because it consists of the multiple bonds, and this is the side chain. So side chain is nothing but propyl group. Okay, so it is 3 propyl hex 1,4 diene, hexadiene. Okay, then you have question number 7. This is the epoxide ring. Epoxides are named like this. Say epoxide means 2 carbon will be connected to oxygen. Okay, so you have to number both the carbons where the oxygen is connected. So it is connected in 1, 2, 3 position. So it is 2, 3 epoxy pentane. Okay, then we have this one. Say question number, example number 8. This one has a epoxide with a substituent. Okay, so epoxides and bromine, if you see the priority order, then this halogens gets more priority compared to your epoxides. Okay, so it is 2 bromo 5 6 epoxy heptane, means numbering will start from this side wherever substituent is, means wherever the halogen you are getting easily. Okay, then this one, this is also, just don't consider it as a cyclic ring, it is just a straight chain, 1 2 3 4 5 carbons, and 2 and 4 position you have a epoxide functional group. So it is 2 4 epoxy 3 methyl heptane. Just while writing this substituents, now you have to follow alphabetical order. Here bromine comes, B comes first, that's why you are writing bromo first and then E. Here also E comes before M, so E is written first. Then say example number 10, it is ester functional group. So esters are written like this. Say this one, no? Say OR, the R that is attached will be written in substituent, and the remaining ester will be written as suffix. Okay, so this is a 2 carbon ester, so it is ethyl, so it will be ethanoate, and since this R group means in the oxygen that is attached is methyl, so it is methyl ethanoate. Okay, the next example number 11, here we have acid chloride functional group. So numbering will be starting from this carbon 1 2 3 4, because this is the longest chain where the double bond is also present, and this is a side chain. So same thing, side chain, just we did in example number 3 na. Side chain, what you have to do, you have to name it separately and you have to write in brackets. Okay, so this is 1 2 3, in 3 position you have chlorine, so it is 3 chloropropyl. Okay, 3 chloropropyl, and this whole side chain is present in 2 position of the main chain, so it is 2, then bracket 3 chloropropyl, and then since 4 carbons are there, so it is but 3 position you have double bond but 3 in 1 oil chloride, because if you have acid chloride then we write this oil chloride in the suffix. Okay, that thing you will be getting in this table. You see, for acid chloride we write oil chloride. Okay, this is acid chloride. So let us come to example number 11. This is a thiol group, say thiol groups, and you have a carboxylic acid group. Okay, so carboxylic acid is a type B functional group and thiol is a type A functional group. Okay, so what we will do, say carboxylic acid gets more preference, so it is written in the suffix, and this thiol is written in the prefix. So it is in prefix, it is written as mercapto. Okay, in 3 position we have a mercapto, and 2 position you have a methyl, and total you have 3 carbons in the longest chain, so it is 3 mercapto 2 methyl propanoic acid. Okay, 3 carbons means propane, so it is a propanoic acid. Okay, then you have this example number 13. Example number 13, it is an amino acid. So in you just see why this example I have chosen. In this one you see both the ends, they have carboxylic acids, okay, as functional group. So you might think that you can start from any side, okay, but you have to start numbering from this carboxylic acid. Okay, why? Because you see in the second position you have amine, and if third position you get hydroxy. Okay, if you come from top to bottom, you will get in second position OH and third position amine. Here what you have to do, you have to follow alphabetical order. Okay, so since amine is getting higher preference due to alphabetical order, so we'll start numbering from bottom to top. Okay, so it is 2 amino 3 hydroxy butene 1,4 dioic acid. Okay, so these are few examples from this IUPAC nomenclature. I have tried to take all this different functional groups. So what you have to do, you just go through different examples. Say any compound you get in your textbook, just try to write the IUPAC nomenclature for this different compounds. Okay, so in the next video we'll be discussing about the IUPAC nomenclature of cyclic compounds, bicyclic compounds, and spido compounds. Okay, thank you.